What? No, it's not radian. Theta, cosine, theta, and tangent, theta. So far, we have learned that these are applicable for what kind of triangle? Right angle triangles. Okay? And theta will either be here, theta number 1, or theta number 2 over here, right? What is the maximum value of theta? Okay, below 90, you all agree? Theta cannot be 90, it must be less than 90, right? All agree or not? Because it is a right angle triangle. Okay? No matter how you draw your right angle triangle, if you draw it like that, this being a right angle, theta cannot be 90. Because once theta is 90, this being on 90, once theta is 90 degree, right, then you cannot get a triangle anymore. Am I right? Okay. Then, are we therefore restricted to theta being ranging from 0 to 90 degrees? Because theta cannot be 0 also, right? If theta is 0, then I'll get a straight line, and then I cannot complete my triangle. Get it? Okay. So, am I restricted to theta is from 0 to 90? Yes. Sounds like we are. Can you use your calculator and verify? Whether it is sine, cosine, or tangent. Try something less than 0, try something greater than 0. Oh, sorry, greater than 90. Can or not? Can I have theta less than 0? Yes. Possible? Did any of you get an error? You just get a negative answer, right? So it is not an, okay, for some of you got negative, okay? Some of you got positive. But is there an error when you chose theta to be less than 0? No error. So it is possible. But what does it mean? Okay, never mind, let's leave that to later. Can you try theta greater than 90 degrees? Whether it is sine, cosine, or tangent. Key it into your calculator. Who got negative answer? Raise your hand. Who got positive number? Okay. Did anybody get math error? Nobody, right? That means it is possible, no? What does that tell us about theta? It can be more than 90. If it is more than 90, what kind of triangle would that be? Let us try and form a triangle where theta is more than 90 degrees, okay? So this is my 90 degrees. I want to form a triangle where theta is more than 90 degrees. Is this more than 90 degrees? So we are saying that this can be theta. If this is theta, then my triangle looks like this, right? Okay? Is this a right angle triangle? It is not a right angle triangle anymore. So, based on what we learned in Sec 2, can I apply trigo for this? Your sine, cosine, tangent. Based on Sec 2 work. Cannot, right? Because Sec 2 tell you for right angle triangle, sine is this, cosine, tangent, so on and so forth. But now, we are telling you that, hey, you are actually not restricted to right angles, and actually, you have all sorts of triangles that you can use, sine, cosine, and tangent. Hey bro, are you okay? So now let us come up with the definition for sine, cosine, and tangent. We're going to build on what we have learned in Sec 2 for your sine, cosine, and tangent. But this time I'm going to use your x and y axis. What has x and y axis got to do with our trigo? They are very related. Everything in maths, they are related. If you are weak in one, you better make sure you are strong before you move on to the next topic. Otherwise, you're going to have a very hard time. Okay? So now let me just draw a circle. Okay, this is not a very nice circle. Oh yeah, I can. Insert. Where's the shape? Draw. Shape. Okay. Okay, thanks for the very good idea. Why? Okay, right? So this is the origin. This is a circle. Let us give the circle a radius. Let us call the radius r. Radius, r for radius, okay? So this circle has radius equals to r. So can you tell me what is this value over here? This is r. What is this one? Are you sure negative r? This is also r. What about this? Negative r. What about this one? Negative r. What about this length? Length, huh? R. Yes, very good. What about this length? Also R. Okay, take note of the difference between length and value. For example, over here, we say that this value is negative R, but if I were to find out the length, it is still R. Get it? Okay, good. Now, I'm going to form a right angle triangle over here. Can you see the right angle triangle? What is the length of the hypotenuse? Good. This is R. That's the length. For this right angle triangle, if I call this point x1, you're okay with this point being x1? Should be familiar, right? We've done coordinate geometry already. If this point is x1, what do you think is a very creative way to call this value? Y1, yes. So this coordinate over here must be x1, y1, right? Okay, now's the interesting part. I will define theta. I define theta to be an angle starting from x-axis going anti-clockwise. It is a definition. It's just a definition. Okay, so what does it mean? Where is my theta in this case? Where does it start from? It starts from the x-axis. I am going to highlight the x-axis over here. Okay, it starts from the x-axis and it goes what direction? Anti-clockwise. From now on, when I draw my angles, it is not going to be like that. It's not going to be like that. I want you to look closely, and I hope you have this habit. When you draw your angles in such a diagram, you start from the x-axis, you go anti-clockwise like this, and you draw an arrow. Okay, to remind yourself, okay, I am going anti-clockwise. This is the angle. So now my angles are going to be this little curved arrow. Okay, so far? I will call this theta. Alright, so this is my angle theta. Let us use our sine, cosine, and tangent again. Because right now I have a right angle triangle. So let us use my Sec 2 knowledge. Sine theta equals to, can you tell me the answer? Sine. Sine will be? Come on, your trigo ratio, what does that tell you? Sine theta is? Opposite. Okay, opposite. What is the opposite length? Y1. Y1 divided by R, which is the hypotenuse, right? What about cosine theta? X1 over R. And our tangent theta? Tangent, opposite first. So Y1 over X1. Okay? Now, have you learned anything different from this diagram? Besides the angle starts from x-axis, go anti-clockwise. Have you learned anything different? No, right? So far it's just this, but we are going to extend this to this part. Okay? This is a circle. It is divided into 4 quadrants. 4 quarters. So for a circle, we call it 4 quadrant. This is quadrant number 1. Which is what our basic Sec 2 trigo works with. Now we are going to go into quadrant number 2. We go anti-clockwise. For some reason, we always go anti-clockwise. In which topic do we go anti-clockwise also? Shoelace, right? Here we also go anti-clockwise. See the angle go clockwise? Anti-clockwise. This is quadrant number 1. This is quadrant number 2. This must be quadrant number? This must be quadrant number? 4. Okay. So now we have changed our sec2 trigo ratio into this form. We are no longer going to be using opposite, adjacent, hypotenuse. We're going to be calling it sine theta is y over r. Cosine theta is x over r, tangent theta is y over x. Okay? Because within the first quadrant, whatever your theta is. I give you another example. For your first quadrant, suppose this is my next theta. This is theta number 2. Okay, in blue color. This will be my x2 and this will be my y2. So we have x2, y2. Just focus on this question. Focus on the blue one, blue triangle. Okay, theta 2. Tell me, what is an expression for sine theta 2? y2 over r. Is it still the same r? Why? Why is it the same r? It is the same radius, it's the same circle. So for sine theta 2, it is still y, but this side is y2. Okay, based on the coordinate y2. And now what about cosine? Cosine theta 2? x2 over r. So instead of x1, we have x2. And finally, theta 2, tangent theta 2 will be y2 over x2. You get it? So now this is our new definition. I'm going to extend it over to our second quadrant. We're going to remove all these ones over here because this is now what guides me for my trigo ratio for angles more than 90 degrees. Because last time, Sec 2, you only learn up to less than 90 degrees. Okay? With your opposite, blah, blah, blah. But now we're going to use x, y, and r. So I'm going to draw a triangle and another line on the quadrant number 2. And this is what it looks like. Let us use the red one. Okay, so here in red, we have theta 1 so far. I am going to draw theta 2, but this time theta 2 is from the positive x-axis and it goes beyond 90 degrees to this side. Okay, let me try and draw something symmetrical. Okay, so this is now my theta 2. So because I very deliberately drew it symmetrical. This point, can you tell me the x coordinate of this point? If it is symmetrical, I deliberately drew it that way. Negative x1, yes, you are right. What about this y value? It is still y1, right? Okay, so for this particular triangle, for this particular question, if I have sine theta 2, what is sine theta 2? Y? Y1 over r. Why is it y1? Because my definition is that sine will be the y value divided by r, which is the hypotenuse, which is fixed in this case. It is a circle. So for theta 2, my sine theta 2 will be y, but in this case it's still 1, same, divided by r. So cosine theta 2, theta 2 will be x2 over r, right? And finally, wait, is it x2 over r? Okay, cosine theta 2, cosine. Our cosine formula says that it should be the x coordinate divided by r. What is the x coordinate? What is the x coordinate for theta 2? Negative x1. So this is negative x1 over r. Okay? And finally, our tangent theta 2 is, what is the value? y1 over negative x1. What does this mean? Just change the thing to negative. Is it really true that we change everything to negative? Just part of it. Okay. Now, answer this question. Is x1 positive or negative? Is x1 positive or negative, everybody? Positive, right? Because x1 is over here. Is r positive or negative? Radius. Positive. Okay, so this x over inside the first quadrant, x1 earlier on where there was all these one, where there were all these ones, theta 1, theta 2, sorry, all these theta 1s, 1, 1, 1. When theta 1 was less than 90 degrees, I had sine theta 1 is y1 over r. Is y1 a positive or negative answer number? Positive. Positive divided by positive is positive. X1 was positive. Positive divided by positive is tangent. Y1 divided by x1 give us positive. Now, let us try for theta 2, where theta 2 is greater than 90 but it is less than 180. Okay? Y1, positive or negative? Positive. Positive divided by positive is positive. Try your calculator right now. Sine theta, where theta is greater than 90 but less than 180. What do you get? Positive number. Yes, exactly. You can try any positive value for theta greater than 90 but less than 180. You should get a positive answer. So what do you think I'll be asking you to do next? Cosine. Now, we said that x1 was positive, isn't it? So if x1 is positive, then minus x1 must be negative. Minus x1 divided by r must be negative. Okay, so we are saying that this is negative. Try calculator. So cosine, a number greater than 90, less than 180. What do you get? Negative, right? And finally, for tangent. Tangent, positive divided by negative. You should get negative. Convinced already? Negative, right? Okay, so right now, I want you to take a look at relationship. Out of all these, I've got theta 1 and theta 2. Do you think sine theta 1 is actually equal to sine theta 2? The value. Yes. Where theta 1 looks like this and theta 2 is symmetrical. Do you think sine theta 1 will be the same answer as sine theta 2? Yes. Who says yes? Why? Where got same number? You mean y1 and y1, r and r, is it? Okay. How do you prove that? I mean, how do you convince some other people that, hey, these two should be the same? Wait, let's try putting random values. If theta 1, give me a value for theta 1. Huh? What? 30. Okay, if let's say theta 1 is 30, then what must theta 2 be? Yeah, more than 90, but how much? I already said they are symmetrical, right? So if theta 1 is 30, I zoom in some more for you all. If this is equal to 30 degrees, how much is theta 2? How you know it's 150? Because 90 minus 30 is? Then what? Wait, 90 minus 30 you get 60 and then? 60 plus 90. Okay, so listen, you all may have different methods. Some will be correct, some may have errors. Let me tell you how to do this. I said it is symmetrical, right? So if this is 30 degrees, shouldn't this also be 30? Right? So this must also be 30 degrees. And now, look at how I draw the angle. Do I have arrow? Did I draw an arrow? Don't have, okay, because I am not starting from the x-axis over here and going this way. I'm just talking about this value. This is also 30 degrees. So if that is 30 degrees, how much is theta 2? 150 or 120? 150. Okay, theta 2 is equal to 1, 5, 0 degrees. Alright? The way to find theta 2 is simply 180 minus 30 to get 150. Okay? So, let's go back to my original question, where I was asking you whether our sine theta 1 and sine theta 2 will give us the same answer or not. So Cosby said yes, and that we should randomly choose a value 30 for theta 1. So now theta 2 will be 150 degrees. I want you to key in your calculator your theta in pairs or in threes. Somebody do sine 30, somebody do sine 150. Are both the same answer?
Yes.
Yes, right. So that tells us that actually sine theta 1 is equal to sine theta 2, provided that this theta 1 and this theta 2, when I draw it like this, it is symmetrical. And I told you how to calculate theta 2, which is 180 minus theta 1. So from here, it appears to be that actually sine theta is equal to sine 180 degrees minus theta. Right? According to that one example that you just did. Now in pairs in threes, I want to randomly choose values of theta where theta is between 0 to 90. Okay? Try theta, we already tried 30. Somebody tried 20, somebody tried 15, so on and so forth. Check whether they are the same or not. Okay, are you all convinced that they are the same? Okay, based on this and this, it appears that they have a relationship again. Is cosine theta equals to cosine 180 degrees minus theta? Are they the same? Must add a negative. Where? At where? Over here? Okay, let's check whether it is the same. Huh? What, you mean bracket over here? No need. Okay, so why is it that we are putting a minus over here? Because here we have x1 over r. x1 over r, whereas over here I have negative x1 over r. So based on this derivation, this way of deriving, it looks like it should be cosine theta equals to negative cosine 180 degrees minus theta. So in your pairs again, can you use your calculators to verify? Okay, Matthew, choose a value of theta. Yes. Okay, cosine 60 degrees. Use your calculator. How much is cosine 60? Half again. Wow, you all like this half a lot. Let us find what is cosine 180 degrees minus 60 degrees. Wait, I'm talking about cosine first. Just cosine 180 minus 60? Negative half. So if I put a negative over here, then I'll be a negative over here, right? So I get half. Am I right? So now we have just proven that there is a relationship again. Cosine theta is negative 180 degrees minus theta. Flip to your textbook, page 12.